Welcome to EPG Pathashala. I am Pingali Shailaja from the Center for English Language Studies of the University of Hyderabad. Today's module is Coining Words from the paper Psychoneurolinguistics. The objectives for today's module are to explain the manner in which words are constructed with particular focus on morphological structure. Also, we will illustrate the different principles that apply in coining words using different types of data from children's and adults' speech. Let us first look at types of data. Data can be spontaneous speech data, including errors. Data can also be experimentally derived. Both children's acquisition data and adult constructions are relevant for our study. There are different modules to describe the process of word construction. We will look at one model of word production, which is a two-stage model. Producing any utterance involves several steps: conceptualization, formulation, and articulation. In the production of words, this translates into knowing the concept that is to be communicated and retrieving the appropriate word for this through a process of activation. The concept is then encoded with grammatical features or syntactic properties that are associated with it. Such encoded forms are lemmas. Lemmas are then codified with appropriate phonological features such as syllabification, stress, and so on. The final output is the audible form or the lexeme. There are many principles involved in coining words. Both adults and children coin words primarily to fill semantic gaps. Some of the principles that we will be discussing are transparency and simplicity of form. Next, productivity. And finally, the issue of setting up of paradigms, that is regularity. It is noted that perception, comprehension, and analysis of words often precede building up of words, but the process is not necessarily linear. Sometimes, as children learn to analyze words, they begin to use them in producing new words. The differences between adult speech and children's speech are that children have fewer words in their mental lexicon. Consequently, they create more new words, and often these words may be considered to be illegitimate, whereas adults have more words at their command, and so the number of words that they construct tends to be fewer. For example, children may construct words like garden man or goodest. Adults, on the other hand, would have the words gardener and best at their disposal. Children generally begin to construct words by the ages of 9 to 20 months. At this stage, they usually create single word units. By the age of 1 year, they begin to construct two-word units. By the time they are 2 years old, they start to combine words and also add morphological modulations onto words. By the time children are 10 or 12 years old, they have a large vocabulary and complex structures at their disposal. Children analyze words into component parts quite early. At the age of 3 plus, a child said, eggnog comes from egg. But sometimes children also fail to analyze words. So a child said, I am Spider-Man woman. Experimental data also show us that children interpret words fairly accurately. And experimental data also shows that they move from form to meaning. A very famous experiment called the WUG experiment was conducted. In the picture in front of you, there is a protocol of a bird-like creature, and under it there is a statement, this is a wug. Next, there are two of the same and words beneath that say, now there is another one. There are two of them. There are two blank. Children were asked to fill in the blank. By the age of 5 to 7 years, children produce the form correctly as wugs. Now this word is obviously coined by rule formation. The plural is created, it is not learnt, because the word wug is new and children would not have had access to it before. We now look at transparency and simplicity. Transparency and simplicity are related to the matter of complexity. The wug experiment had a number of other items also for children to produce. One set was for children to produce plural allomorphs, the allomorphs being sir, zer and is. Children were found to be more successful with sir and zer and less successful with is. Here the notion of simplicity or complexity plays a role. The simpler forms sir and zer were produced more easily. The slightly more complex form of is was not produced that easily. Also, along with this, it was seen that familiarity played a role. Children were more successful with the word glasses, with which they would have been familiar, rather than with tasses, which is a created word. We notice something similar in the case of Telugu as well. In Telugu, there is a process called vowel harmony, where a vowel changes its quality when the plural suffix lu is attached. For instance, pilli, which means cat, is pillulu, cats in the plural form. Likewise, puli, tiger, is pululu in the plural form. But children tend to say pillilu and pulilu. This is because of the complexity of the matter. Phonological complexity also delays learning of the correct plural form. When we move to derivations and compounding, again we find that simpler forms are acquired earlier by children. In English, zero-derived words or words that are derived through conversion appear first. So we find children creating words like to car when they want to use the meaning drive, or they say to piano to mean play the piano, or to bell to mean ring the bell. Morphological simplicity is the obvious explanation for this type of construction. At the same time, however, children also produce compounds early enough. Compounding is a very productive process in English, and as a result of this productivity, we conclude that compounds appear earlier in the speech of children. Compounding is also a very productive process in Indian languages. In Telugu compounds, we notice that complexity of the compound makes a difference to children's ability to produce and segment them. When two words are brought together to form a compound, like Gunde Jabbu or Madata Mansam, and there is no change when this compound is constructed, children are able to segment these structures fairly accurately. They are also able to produce these structures fairly well. But when there is some change in the construction of the word, then we find that their performance levels drop dramatically. So when there is vowel change, as in the word Chintaku, where a vowel is dropped, or Mandula Dabba, where a vowel is changed, their production level drops to 58.33% and segmentation drops to 33.33%. On the other hand, when there was no change, their performance level was very high at 98.33%. We now move on to other phenomena mostly from adult speech, which give us insights into how words are retrieved. Spontaneous speech phenomena give us insights into word retrieval and construction. Of the many phenomena, one is substitutions. We have examples like this. When the intended utterance is "must you leave? It's still so early." The actual utterance could be "must you leave? It's still so late." This shows us that competitive and associative lemmas get activated from a concept. Insertion of the wrong lemma could be due to several factors, one of which could be greater frequency of occurrence of the wrong lemma, or greater imageability of the word inserted over the target word, or even just not being able to retrieve the target word for some reason. Notice that this phenomenon is being explained in the two-stage model that we discussed earlier. Another set of phenomena that we often observe in spontaneous speech is blends. The examples given there are stomach and tummy lead to the production of stomach, or stiffer and tougher can lead to the production of stuffer. In this case, we think that two closely related competitive concepts are activated at the same time. The concepts in turn activate different lemmas, and when there is no resolution between the concepts, both the activated lemmas get inserted at the same time. This leads to the construction of blends. Another set of phenomena is the tip of the tongue errors. Speakers are often able to retrieve some parts of a word. Often it's either the first part or the last part that is recalled. Recalling the first part shows us that the beginnings of words are important. Recalling the last part shows us that suffixes are important. Experimental data also shows us that speakers are able to recall some phonological or grammatical features of a word rather than the full word. This tells us that lexical knowledge does not mean storing of the word in its entirety in the mental lexicon, nor does it mean that we are able to retrieve a word in its entirety when we require it. Another set of data are called stranding errors. When someone says "it sounds up" and corrects themselves as "ends up sounding like split," what they intended to say was "it ends up sounding like split." The word that is to come later in the sentence is moved forward, and the affix that is to be attached to the first word is attached to the wrong word. Another example is "you just count wheels on a light," the intended utterance being "you just count lights on a wheel." These errors show us that complex words are constructed in real time. But we also know that some words have to be stored as whole words in the mental lexicon. For example, irregular plurals like children must be stored in the lexicon. So we claim therefore that two processes are in place for construction of words. Among stranding errors, both derivational and inflectional affixes are involved. For example, take the freezes out of the staker. The intended utterance is "take the steaks out of the freezer." In this case, the derivational affixes and the inflectional affixes are interchanged. Likewise, "fancy getting your model renosed" for "fancy getting your nose remodeled." The appearance of errors of this kind tells us that the distinction between derivational and inflectional affixes is probably not useful, and the notion of productivity is a more useful phenomenon in examining words and their construction. To summarize all that we have looked at today, we see that There are different kinds of data that enable us to understand the process of coining words. The data can be data of language acquisition or speech errors. The two-stage model of word access and building is one of the models that's been proposed in the literature, and it helps us to explain some of the phenomena that we observe. Language acquisition data help us to understand how rules are framed and how children ascribe meanings to the component parts of complex words. From speech errors of different kinds, we understand the processes of activation that lead to the construction of different types of words. The main principles that are relevant to coining words are familiarity, simplicity, productivity, and regularization. I hope you have understood the main concepts that have been presented in this module. For further clarity on the matter, do refer to the e-text that is available and also look up the useful resources that have been listed in the module. Thank you.